Imagine you're standing in a welding shop for the first time. A welder walks by and says, "Turn up the amperage." Another says, "That weld failed because of porosity." Someone else asks, "Are you running DCEP or DCEN?" Suddenly, it feels like you've stepped into a foreign country where everyone speaks a language you don't understand. And here's the truth. Many beginner welders struggle not because they can't weld, but because they don't understand the terminology. Welding has its own vocabulary, and if you're serious about becoming a skilled welder, fabricator, inspector, or welding engineer, understanding these terms is just as important as learning how to strike an arc. In fact, understanding welding terminology can help you communicate like a professional, read welding procedures correctly, troubleshoot welding problems, pass welding certification exams, improve weld quality, increase workplace safety. In this guide, we'll break down the most important welding terms every welder should know, explain them in simple language, and show why they matter in real-world welding applications. Some of these terms are used every day in fabrication shops around the world. Others are critical if you plan to advance your welding career. By the end of this video, you'll understand welding conversations that once sounded confusing and technical. Let's get started. What are welding terms and their meanings? Welding terminology refers to the technical words, abbreviations, processes, measurements, and concepts used throughout the welding industry. These terms help welders communicate accurately and ensure that everyone involved in a project understands exactly what's required. Let's explore the most important ones. 1. Amperage, current. One of the first terms every welder encounters is amperage. Amperage, often called current, is the amount of electricity flowing through a conductor. Think of it like water flowing through a pipe. The more water flowing, the greater the force. Similarly, higher amperage means more welding heat. Amperage directly affects penetration, weld size, travel speed, weld quality. Too little amperage may result in weak welds. Too much can burn through the material. Learning to control amperage is one of the foundations of welding success. 2. Arc. The arc is the heart of most welding processes. It is the electrical discharge created between the electrode and the base metal. This arc generates extreme heat, capable of melting metal and forming a weld. Temperatures inside a welding arc can exceed 10,000 degrees Fahrenheit or 5,500 degrees Celsius. Without the arc, there is no welding. That's why experienced welders spend years mastering arc control. 3. Direct current, or DC. Direct current, or DC, is electrical current that flows in only one direction. Many welding machines use DC because it provides stable arc performance, better penetration, smoother welds, easier arc starting. DC is especially popular in stick welding and TIG welding applications. 4. Alternating current, or AC. AC changes direction repeatedly. In the United States, standard AC power operates at 60 Hz. AC welding is commonly used for aluminum welding, certain TIG applications, and specialized fabrication work. Because AC constantly changes polarity, it offers unique cleaning action when welding aluminum. 5. DCEN. DCEN means the electrode is connected to the negative terminal. This setup is often called straight polarity. Benefits include deeper penetration, higher travel speeds, concentrated heat in the workpiece. It's commonly used in TIG welding. 6. DCEP. DCEP means the electrode is connected to the positive terminal, also known as reverse polarity. Advantages include better arc stability, improved cleaning action, and enhanced electrode performance. Many stick welding electrodes require DCEP. 7. Duty cycle. One of the most misunderstood welding terms is duty cycle. Duty cycle refers to how long a welding machine can operate continuously within a 10-minute period before overheating. For example, a machine rated at 60% duty cycle at 300 amps means it can weld for 6 minutes and must cool for 4 minutes before welding again.
Higher duty cycles are essential in industrial welding environments.
AWS. AWS stands for American Welding Society. This organization develops welding standards, certifications, codes, and educational materials. Many welding qualifications worldwide follow AWS standards. AWS D1.1. AWS D1.1 is one of the most widely used welding codes in the world. It governs structural steel welding and provides requirements for weld quality, inspection, procedures, and qualification testing. If you're involved in structural steel fabrication, you'll likely encounter AWS D1.1 frequently. Autogenous welding. Autogenous welding is welding performed without filler metal. Only the base metals are melted and fused together. This method is common in certain TIG welding applications and thin materials. Automatic welding. Automatic welding uses equipment that performs the welding process with little or no operator adjustment. The system automatically controls travel speed, arc length, joint tracking. Automation improves consistency and productivity. Constant current WM. Constant current machines maintain relatively stable current even when arc length changes. These machines are commonly used for stick welding, SMAW, and TIG welding, GTAW. They provide excellent arc control. Constant voltage WM. Constant voltage machines maintain stable voltage output. They're commonly used for MIG welding, GMAW, and flux cord welding, FCAW. CV machines automatically adjust current as arc conditions change. MIG welding, GMAW. MIG stands for Metal Inert Gas Welding, officially known as Gas Metal Arc Welding, GMAW. This process uses continuous wire feed, shielding gas, and electric arc. MIG welding is popular because it's fast, easy to learn, and highly productive. TIG welding, GTAW. TIG stands for Tungsten Inert Gas Welding, officially known as Gas Tungsten Arc Welding, GTAW. This process uses a non-consumable tungsten electrode, shielding gas, and optional filler rod. TIG welding produces some of the cleanest and most precise welds available. FCAW, Flux Cord Arc Welding. Flux cord arc welding uses a tubular wire filled with flux. Advantages include high deposition rates, strong penetration, and excellent outdoor performance. It's commonly used in construction and heavy fabrication. SMAW. Shielded metal arc welding, commonly called stick welding, remains one of the most widely used welding processes. Benefits include simplicity, portability, and reliability. It's particularly useful outdoors. 18. Shielding gas. Shielding gas protects the molten weld pool from contamination. Common shielding gases include argon, helium, carbon dioxide, and mixed gas blends. Without proper shielding, weld defects can occur. 19. Weld metal. Weld metal is the material that melts and solidifies to form the weld bead. It consists of melted base metal and filler material. This is what ultimately joins the components together. 20. Weld transfer. Weld transfer describes how molten metal moves from the electrode to the weld puddle. Different transfer modes include short-circuit transfer, globular transfer, spray transfer, and pulsed spray transfer. Each affects weld appearance and performance differently. 21. Defect. A defect is a weld condition that exceeds acceptable quality standards. Examples include cracks, porosity, lack of fusion, and slag inclusions. Defects often require repair or rejection. 22. Discontinuity. Many beginners confuse discontinuities with defects. A discontinuity is simply an interruption in the normal structure of a material. Not every discontinuity is a defect. Only those exceeding code requirements become defects. 23. Porosity.
Porosity consists of tiny gas pockets trapped within the weld. It can weaken weld strength and appearance. Common causes include contamination, moisture, and poor shielding gas coverage. 24. High frequency. High-frequency current is often used in TIG welding. It helps start arcs without touching the metal, stabilize the arc, and improve weld quality. This feature is particularly useful when welding aluminum. 25. Hertz, Hz. Hertz measures frequency. In electrical systems, Hertz indicates how many times current changes direction each second. Standard AC power in North America operates at 60 Hertz. 26. Inverter welding machine. Modern inverter welders use advanced electronics to convert power at much higher frequencies. Advantages include smaller size, lighter weight, better efficiency, and superior arc control. Most modern welding machines use inverter technology. 27. Plasma arc cutting. Plasma cutting uses a constricted electric arc and high-velocity gas stream to cut metal. Benefits include fast cutting speed, precision, and ability to cut conductive metals. 28. Spot welding. Spot welding joins overlapping metal sheets using pressure and electrical current. It's widely used in automotive manufacturing, sheet metal fabrication, and appliance production. 29. Stud welding. Stud welding permanently attaches fasteners to metal surfaces. It's commonly used in structural steel construction, shipbuilding, and manufacturing.
30. Submerged arc welding, SAW. Submerged arc welding uses granular flux to cover the welding arc. Benefits include deep penetration, high deposition rates, excellent weld quality. It's commonly used for large industrial fabrications. 31. Torch. In TIG welding, the torch is the tool that holds the tungsten electrode, delivers shielding gas, conducts electrical current. Proper torch control is essential for producing quality welds. 32. Tungsten. Tungsten is a rare metal with an extremely high melting point. Because of its heat resistance, it serves as the electrode in TIG welding. 33. Touch start. Touch start is a TIG arc starting method where the tungsten briefly touches the workpiece before the arc is established. This reduces tungsten contamination while avoiding high-frequency starts. 34. NDT, NDI, and NDE. These terms relate to weld inspection. NDT, non-destructive testing. NDI, non-destructive inspection. NDE,
Non-destructive examination. All are methods used to evaluate weld quality without damaging the part. Common NDT methods every welder should know. These inspection methods are frequently used throughout the industry. Visual testing, VT. Penetrant testing, PT. Magnetic particle testing, MT. Eddy current testing, ET. Ultrasonic testing, UT. Radiographic testing, RT. Leak testing, LT. These methods help ensure welds meet safety and quality requirements. Why learning welding terms matters. The best welders aren't just skilled with a welding torch, they understand the language of welding. Knowing these terms helps you communicate professionally, understand welding procedures, interpret blueprints, pass certification exams, improve troubleshooting skills, and advance your career. The more welding terminology you understand, the more confident and capable you'll become in the shop. Conclusion. Every professional welder started exactly where beginners are today, trying to understand a long list of unfamiliar terms. But once you learn the language of welding, everything becomes easier. From amperage and polarity to TIG, MIG, FCAW, duty cycle, and weld inspection methods, these terms form the foundation of welding knowledge. Mastering them will help you become safer, more productive, and more confident whether you're welding as a hobby, pursuing certification, or building a professional career in fabrication. Remember, great welders don't just know how to weld, they understand why welding works. And that understanding starts with the terminology.
If you found this guide helpful, make sure to hit the like button, subscribe to the channel, and turn on notifications for more welding tutorials, fabrication guides, inspection tips, and industry insights. And here's a question for you. Which welding term confused you the most when you first started learning to weld? Let us know in the comments below. Thanks for watching, and we'll see you in the next video.